Hello everyone. Good morning. I am Manoj Deshpande. Currently, I am pursuing my PhD in digital media at Georgia Tech. My paper is titled Towards CoBuild, an architecture machine for co-creative form making. It is co-authored by Professor Eric Sauda and Dr. Maher. This paper is largely based on the work that I did during my master's thesis at University of North Carolina, Charlotte. So to continue, the presentation is organized into 8 sections, and the first one is motivation. So currently in the field of architecture, though AI has been incorporated at various stages of architectural design, within the field of architecture, AI is largely described using words like disruptive or evolutionary, or even like intelligent tool or one-touch design. With always a looming fear that AI will one day replace architects, and rightly so, because currently most of the AI projects in architecture ignore designers completely, or the designer's role is reduced to just choose from an array of design options generated by AI. So this motivated me to work towards a human in the loop system in which the machine becomes a partner rather than just a tool. Uh, so the main motivation behind CoBuild comes from Negroponte's proposal, Negroponte's Manifesto of Architecture Machine. In 1970, Nicholas Negroponte proposed the idea of man-machine symbiosis, in which he envisioned a relationship with the machine not as a master and a slave, but that of a partnership. But nearly after 5 decades, computers still serves as a subordinate to the designer, at least in architecture. So this research explores this man-machine symbiosis and proposes CoBuild, a step towards building an architecture machine. So moving on, in this section of related works, I talk about background and situate CoBuild in co-creativity context. To first, like to reduce the scope of the research I began with, I focused on massing models. So in architecture, massing models are the rough sketch models that are made very early on in the design phase. But even though they are like made very early on in the design phase, they are fairly complex in terms of the fact that they involve a lot of non-quantifiable parameters like political agenda of a designer or emotions, etc. So to simplify the problem further, we focus on architectural design games. So even Negroponte in his manifesto talks about how games can be utilized by machines to self-improve. Also, as highlighted by Mark Ross here, games provide tractable environments where design can be studied. There are many games. There are many collaborative design games, for example, community land use games. But for this research, we explore concept design games. So the concept design games was developed by Mark Ross and John Heberkin. They proposed 9 games and each focusing on a unique concept. Out of those 9, 2 games are based on interaction and one of them is silent game. So in this game, the silent game, the players are first not allowed to talk to each other. And as you can see in the figure, the first player places the nail vertically, and then the second player continues to add to the pattern and then adds his or her own pattern by adding the horizontal nails. And this goes on until one of the players decide to put a washer. And as a result of this collaboration, you see a pattern emerge on the board. So I adopted this game for my research, but with a variation. We proposed 2 variations of the silent game based on the interaction, that is the switch silent game and the simultaneous silent game. In the switch silent game, as the figure on the left, the players take turn while placing the blocks on the screen. And in the simultaneous silent game, both the players simultaneously add the blocks to the pattern. And there is no fixed agenda, and participants are like completely free to make whatever they wish to do. So now let me like briefly go over my research goals and questions. Uh, so the study just had 3 main research goals. The first one is to understand different circumstances when machine contribution made sense. The second was to understand which type of interaction promote good co-creative experience. And the third one was to extract different aspects of human-human collaboration that can be applied to human-machine collaboration. So, and based on these research questions, research goals, 3 research questions were formed. Namely, the first one was to what degree was participatory sense making present during the collaboration? The second one was what metrics and features did users employ to evaluate if the machine contribution made sense? And the third one was machine considered as a tool or as a collaborator? So with these research questions and goals in background, let me just talk about the system design briefly. So CoBuild is basically a network-based application that lets people collaborate in real time and build a 3D model on the web. It is currently hosted on Heroku and can be accessible at the link. I will share the link in the chat. Uh, so the system, as shown in the diagram, basically consists of a WebSocket Node.js server, which serves multiple web clients, uh, which contains HTML, CSS, and a bundled JavaScript file. All the computation for CoBuild happens on the client side, that's on the front end. The bundled JavaScript file is organized using the MVC pattern. So as shown in the figure, we have two models like voxel and voxel grid. And basically, the main important part here is the view component of it, because view uses 3.js, which is the main library, which lets us to do 3D modeling on the web. And apart from that, the control is basically facilitating communication between the model and view, and is also responsible for setting up the WebSocket connection. So now on to the important part, the evaluation. So since like there are many frameworks, but for this research, we utilize the framework proposed by Keremy et al. So applying this framework to CoBuild, the user evaluates the output of the machine. The evaluation is to study interaction between human-human and human-machine collaboration. The introspective video walkthrough and interviews are utilized, and the metrics that we're trying to measure are collaboration, engagement, and ownership. Moving on, the study was basically designed in three parts. The first one was to familiarize the users with the UI and generally introduce them to the silent game, which lasted for around 4 minutes. Then the participant played the two variations of the silent game, that is the switch and the simultaneous silent game, again, which lasted for around 3 minutes, each with a human collaborator. And during this, the screen was recorded, like the silent game. So moving on to the second part, the participants are first introduced to perceptual logic settings. So based on an active model of creativity proposed by Davis et al. In 2015, perceptual logic dictates what the agent perceives in the environment, and there are three logics, basically local, regional, and global. Since this research utilizes Wizard of Oz technique, in local logic, the facilitator copies the user, and regional logic facilitator completes the structure, and in global logic facilitator just mirrors a portion of the structure. So after the participants are introduced to these perceptual logic settings, they continue to play the two variations of the silent game, but now with a Wizard of Oz machine. And then the third part is when the participants take part in retrospective video walkthrough and the interview. The interview contained 9 questions, and the questions were related to the research questions and metrics. Overall, the data that was generated from the study includes the screen recording from the design task, the audio and transcribed data from the retrospective video walkthrough, which is basically the protocol data, and the transcribed data of the post-task interview, which is basically the interview data. So the user study was conducted online because of the pandemic. It was conducted through Google Meet. 20 participants took part in it, and they were recruited through email. Out of the 20, 8 were female and 12 were male, with an average age of 25. 15 participants had a background in architecture and design, and 5 had a background in engineering or non-design fields. So this slide shows a sample screen record of human-human collaboration during the switch case on the left and the simultaneous case on the right. As you can see, the participants in the switch case take turn to build, since in this collaborations with both human collaborators like take turns, and on the other side you can see that the building is happening simultaneously. Similarly, in this slide, this is a sample screen record of human-machine collaboration. The only difference here is the use of perceptual logic settings on the top here, and that results in different kinds of interaction. But again, in the switch, you see the Wizard of Oz machine and human take turns, and in simultaneous, both go together, depending on the logic. So moving on, a simple comparative analysis was conducted on the interview data, and the interview results are as follows. I won't read all, but like the most important ones. 13 participants preferred simultaneous interaction with the machine as it was more engaging. 5 participants reported that the machine was a tool, and the major reason for this was because it was just basically mimicking all their moves in local setting. And in this, 5 participants reported that machine was more than a tool because they thought that it gave them new ideas, and 11 participants preferred to collaborate with the machine because they had more authority or control over the design, is what came out of the interview. Uh, so moving on, an inductive thematic analysis was conducted on the protocol data for both human-human and human-machine collaboration. And based on the analysis, we identified 3 themes and classified the data amongst those 3 themes, basically participatory sense making, interaction dynamics, and emergent form making. In participatory sense making for human-to-human collaboration, like 19 participants expressed that they got new ideas, and everyone acknowledged that the final form was a result of 2 people working together. And for interaction dynamics, it was seen that there was like 2 prominent way that the people behaved. One was either to build uh, the structure and join the structure to what the collaborator was doing, or to build their own structure in response to what the collaborator was doing. And participants preferred turn taking during the human-human collaboration because it gave them more time to reflect on what was happening on the screen. And in terms of emergent form making, all participants expressed that the form was not initially thought of, and it just came because of the collaboration that they were having. Similarly, for the human-machine collaboration, the participatory sense making was much lower. Only 3 people expressed that they got new direction or new idea. The dominant trait during the interaction dynamics that was identified is that of a testing model. Few participants deliberately added random logs and wanted to see if the machine detects any pattern. Again, authority and control over the design was something very prominent. It was also interesting to note that engagement was higher in the simultaneous interaction as compared to the switch interaction. So in terms of ownership, it was seen that 19 participants claimed sole ownership of the design that was made, and the ownership changed with the perceptual logic setting. It was highest in the local because the machine was basically mimicking. It was least in the global. Yeah, so in this slide, I relate to the collaboration metrics. Again, as I said before, moving on, next I talk about conclusion. So to answer the first research question, the participatory sense making was higher in human-human collaboration. Participatory sense making was higher in the simultaneous case, and it occurred more in the regional and in global setting. The participants repeatedly said that the machine should not mimic because they thought that it would be good if it was much more provoking. And to answer the second research question, pattern mimicking, pattern continuation, and similar patterns were one of the dominant traits that people utilized. And in terms of visual design principles, symmetry, continuity, repetition, and proximity were the dominant visual design principle. And as I said before, there was a strong correlation between the ownership and sense making. The more ownership that they felt or authority they felt over the design, more likely they said that the design made sense or the contribution by the machine made sense. Now on to the third part, the machine was more than a tool and less than a partner because people said this, 5 people said this, because machine was basically continuing or completing whatever design they had. And 10 people said that the machine was partner because they were not able to completely control the machine or the output of the machine. Next, moving on to the discussion, I highlight 3 interesting points that we came across during the study. So the first one is it was interesting to note that the entity to be considered as a design partner, the bar is set really low. The only difference between any CAD software and COBOL as of now is that COBOL recognizes the command on its own. So and that subtle change makes it a partner. And the second one was participatory sense making is always considered with a human perspective. But when from the machine's point of view, all it does is geometric. It just moves shapes around, and it has no syntactic or semantic meaning attached to it. But yet the contribution by the machine for users made sense. And the third one is using the inactive model of creativity. It facilitates like a data labeling process, which can be used to collect and as well as train the machine in the future. The last thing that I want to talk about is the future work. Uh, so I see this project in which we can incorporate physical computing with the system that we already have, and I also would like to investigate the human machine collaboration, in which basically two humans are collaborating with the same making machine. It would be interesting to see how the machine chooses between different humans' logic. The third is to obviously, as suggested by all the participants, explore the human and non-mimicking agent interaction. I would also like to explore the task-divided co-creativity and definitely like measure different metrics like novelty, creativity, surprise, etc. Uh, Thank you so much for listening. Uh, that's about it.